Hello, welcome back. So today we're going to look at a couple of different theorems on polynomials. So the first theorem that we're going to look at is called factor theorem. So the factor theorem says that if x is equal to a is a zero of the polynomial p of x, then x minus a is a factor of that polynomial. So we can take a look at an example where that is true. So if we have, let's say, the example x is equal to -3, x is equal to 2, and x is equal to 1 plus or minus I radical 7, and we know that these are zeros of a polynomial, then we can write those factors as x plus 3, x minus 2, and x minus 1 plus I radical 7, and x minus 1 minus I radical 7. So we know that those are factors of that polynomial p of x. Another theorem is called the fundamental theorem of algebra. Now, it's extremely important, and what this theorem says is that every single polynomial of degree n has n roots. Now, those might be real or they may be imaginary, but it will have a total of n roots. So that also means that the polynomial will have n linear factors, since for every root a, x minus a is a linear factor. Look at an example, and for our example we will look at the polynomial p of x equals to x cubed minus 3x squared plus 4. So the highest degree of this polynomial is 3, so the degree is 3, which means that it will have 3 roots. Now let's say that the 3 roots that this polynomial has are x is equal to -1 and a double root at x is equal to 2. So knowing this information, that means that it has linear factors of x plus 1, x minus 2, and another x minus 2. This next theorem is called the integral zero theorem, and what this one says is that for any polynomial with integral coefficients, if an integer is a zero of the polynomial, it must be a factor of the constant term. So let's take a look at an example so we can see what I mean by that. So if x is equal to 1, x is equal to 2, and x is equal to 3, and x is equal to 4, if we know those are zeros of the polynomial, then we can write those factors. So x minus 1, x minus 2, x minus 3, and x minus 4. So we know those are factors of the polynomial. Now, we can use this information to understand what the constant term of the equation would be. So if you multiply those factors out, you look at the constant term, and you can figure out the constant term just by multiplying those zeros. So 1 times 2 times 3 times 4 gives you 24. So that means if I multiply out all the factors, my last term, my constant, will be 24. So I multiplied it out for you. You get x to the 4th minus 10x cubed plus 35x squared minus 50x, and then there's that constant plus 24. So that's going to be really, really useful when you're trying to figure out whether a factor is in fact divisible. So here's another theorem, last one. So the remainder theorem says that for any number c, when a polynomial p of x is divided by x minus c, the remainder, so what's left over, is p of c. So for example, if I want to look at p of x is equal to x to the fourth minus x cubed plus 20x minus 48, and I'm dividing that by x minus 5, then the remainder is p of 5. So when you plug in 5 to the fourth plus 20 times 5 minus 48 gives me 552. That will be my remainder. Now, if p of c is equal to 0, then x minus c is a factor. So if you get a 0 as a remainder, then that means it is divisible by x minus c. So for example, if you have p of x is equal to x cubed minus 3x squared plus 4, and x is equal to negative 1 is a root, and you know that, then p of negative 1 will give you 0, which means that x plus 1 is a factor of p of x. So that's a lot of theorems. That's all for today. Thank you for watching.